Alright guys, so this is our video introducing the properties of logarithms, and in this video we're going to talk a little bit about what the properties of logarithms are and how we would use them. We're going to go into a deeper explanation of how we get the properties of logarithms in class, but for right now what we want to do is just get good at using the properties of logarithms. So right here in general we're going to say that the properties of logarithms only extend to logarithms of the same base, right? So the properties that we're going to talk about are only going to be used when we have logarithms that have the same base. So right here, we're going to start with the product rule, our first property. And with the product rule, what we're saying is that if we have a multiplication between two things inside one log, then we can expand that multiplication out into the addition of those two things inside two logs of the same base, right? So if we've got log base b of r times s, that is going to equal log base b of r plus log base b of x. So if we want to expand an expression like log base 2 of 3x, right, where we're seeing a multiplication between our 3 and our x, we can say this is log base 2 of 3 and then plus log base 2 of x. This property also works in reverse. So if we're adding two logs of the same base, what we can say is that we can bring those two logarithms together, condense them into one log, where we're going to be multiplying the two things in the individual log. So right here, if we've got log base 5 of 4 plus log base 5 of y, we can condense this into one log base 5 of 4 times y, or 4y. The quotient rule says that a division in our logarithm is going to expand out into a subtraction of two logs of the same base. So if we've got log base b of r divided by s, we're going to say that that is equal to log base b of r minus log base b of s. And right here, the thing we want to note is that that thing we're dividing by is expanding out into a negative logarithm, right? So right here, if we have log base 4 of x divided by 5, we can say that this division is going to expand out into a subtraction of two log base 4s, log base 4 of x, and then minus what the log base 4 of what we're dividing by, 5. Obviously this rule works in reverse as well. So if we've got a subtraction of two logs of the same base, then we can say we can condense this into one logarithm, where what's inside that negative logarithm is going to be dividing what's inside the positive logarithm. So right here we've got log base 3 of 4 minus log base 3 of 2z, and we can write this as 1 log base 3 of 4 divided by 2z. Right here, what we want to do is sort of generalize the product rule and the quotient rule. And in general, what we can say is that what's inside positive logarithms, when we condense, is always going to be multiplied in the numerator. And what's inside negative logarithms is always going to be multiplied in the denominator. So if I wanted to expand this log base 3 of 4 divided by 2z out, what I could say here, if I want to expand it all the way out past what we started with, what I could say here is that I'm multiplying one thing in the numerator and two things in the denominator. So when I expand this expression out, I can expand it out into three logarithms. I would have one positive logarithm for that 4 in the numerator and two negative logarithms for the things that I'm multiplying in the denominator. So right here I can say that I would have log base 3 of 4 and then minus log base 3 of 2 minus log base 3 of z, right? Where when I expand this expression out, things multiplied in the denominator expand out into negative logarithms, and things multiplied in the numerator expand out into positive logarithms. So right here, that's a general sort of way we want to think about expanding and condensing logarithms, right? Things multiplied in the denominator expand out into negative logarithms. Things multiplied in the numerator expand out into positive logarithms. And we can also think about this vice versa, right? So if we are adding and subtracting logarithms of the same base, the negative logarithms are going to condense down to multiplication in the denominator, and the positive logarithms, what's inside those positive logarithms, is going to be multiplication in the numerator. All right, so our last property of logarithms is going to be the power rule. And the power rule says that if we've got an exponent inside a logarithm, or a power, right, our expression inside our logarithm raised to some power, we can take that exponent and throw it out front and make it a multiplication in front of our logarithm. So if we've got log base b of r to the c power. We can take that power of c and throw it out front and make it a multiplication in front of our log, so we would have c times log base b of r. So if we wanted to expand using the power rule, we could say if we've got log base 2 of 9, that 9 we could think of as 3 squared. And then right here, we can take that square, that power of 2, and throw it out front and make it a multiplication of 2, so that the expanded expression would look like 2 log base 2 of 3. Similarly, this rule works in reverse. So right here, if we are multiplying our logarithm by something, then right here we can take that something and make it a power inside our logarithm. So if right here, if we've got 2 times log base 3 of 2x, we can say this is going to be equal to log base 3 of 2x squared, right? Where we basically bring that multiplication in front, inside, and just make it a power. Now right here we can simplify this a little bit and call this log base 3 of 4x squared. All right, so what we want to do now is talk about how we can expand using these properties. And we're going to move to our next page and look at some problems. So right here, expanding, what we want to think is that we are going to take one logarithmic expression and expand it out into the addition or subtraction of multiple logarithms. And so right here, in general, what we want to think is that before we expand, we want to see the expression inside our logarithm represented as a multiplication and division of bases raised to power. So it may be that we need to simplify our expression before we can actually expand out. And we're going to see that when we go through C. So we're going to go through A, B, and C together, and then I'm going to let you guys try the rest of these on this page. So right here, after we make sure that the expression inside our logarithm is bases raised to powers in the numerator and denominator, what we're going to do then is expand out that logarithm into the addition and subtraction of logarithms of the same base, and then we would take all the powers inside those addition and subtractions of logarithms of the same base and throw them out in front to make the multiplication. So right here, looking at A, we've got the common log of 2x divided by yz, right? So if we're expanding this out, we're already a multiplication of bases in the numerator and denominator. We don't have any powers here, but that's okay. So right here what we would say is we're multiplying 2 things in the numerator and 2 things in the denominator. And what this means is we're going to expand out to 2 positive logs for the 2 things we're multiplying in the numerator and 2 negative logs for the things we're multiplying in the denominator. So right here we can expand this expression out into the common log of 2 plus the common log of x minus the common log of y minus the common log of z. Just had enough room there. And so right here, that would be an expansion of this expression. Now, if that x, y, or z were being, any of those were raised to powers, we would then throw that power, or that exponent, out in front and make it multiplication. So if we're looking at our next expression, I'm going to sort of erase this and make this a little bit more legible. If we're looking at our next expression, b here, we've got log base 3 of 4ab cubed. So right here we're multiplying 3 things, all in the numerator, so this is going to expand out into 3 positive log base 3s. We're going to have log base 3 of 4, and then plus log base 3 of a, and then plus log base 3 of b cubed. Now at this point right here, we can say that that 4 inside our first log base 3 could be 2 squared. So right here, we're going to say this is log base 3 of 2 squared plus log base 3 of a, and then plus our log base 3 of b cubed. And now finally, in our last step, we're going to take those exponents inside the logarithm and throw them out front to make the multiplication. So we're going to have 2 log base 3 of 2 plus log base 3 of a plus 3 log base 3 of b. And that would be our b expression expanded all the way out. So let's take a look at C, and then I'll let you guys go ahead and do D, E, and F on your own. So right here, we're looking at the natural log of 3 times the square root of 2x cubed. And right here, our expression inside our logarithm isn't just bases raised to powers. So right here, what we want to do is simplify that expression first. And what we're going to say is that we can rewrite our natural log of 3 square root of 2x cubed as the natural log of 3, and then right here we could say this is 2x cubed to the 1/2. And now at this point what we can say is that if we distribute that exponent of 1/2, we're going to have the natural log of 3 times 2 to the 1/2 times x to the 3/2. And now right here we can see the expression inside our logarithm as the multiplication of 3 things, and then right here we've got 2 of those things, 2 and x raised to powers. And now right here we can expand out in the exact same way we did before. So right here we're multiplying 3 things, which means we're going to expand out into 3 natural logs, positive natural logs. So right here we're going to have the natural log of 3 plus the natural log of 2 to the 1/2 plus the natural log of x cubed, or x to the 3/2 rather, not x cubed. And now our last step is going to be to take the exponents of 1/2 and 3/2 and throw them out front to make the multiplication. So right here we're going to end up with the natural log of 3 and then plus 1/2 natural log of 2 plus 3/2 natural log of x. And that is the expanded out expression. All right, guys, so we're going to stop our video here and let you guys go ahead and try these last 3. So D, E, and F, you guys are going to give a shot to on your own, and then we'll talk about expanding out polynomial expressions with logarithms after that. Okay. All right, guys, so let's look at the rest of these. Here we've got the common log of 3 times x squared times y cubed. So right here we're looking at 3 things being multiplied in the numerator inside our natural log, right? So right here that's going to expand out into 3 positive logs, right? And then we can take those exponents of 2 and 3 and throw them out front to make the multiplication. Okay, so in our next one, right here, what we're seeing is 2 things being multiplied in the numerator and 2 things being multiplied in the denominator. So the 2 things being multiplied in the numerator are going to expand out into positive logarithms, right? That's that 125 and a squared. They're going to be in positive common logs. And right here, the 2 things being multiplied in the denominator are going to expand out into negative common logs, right? Now right here, this 125 we can represent as 5 to the 3rd power, and then in our next step, what we're doing is taking those exponents inside the logarithms, right, that exponent of 3, 2, and 3, and throwing them out front and making the multiplication. Our final our final expansion right here, log base 2 of 27 over the square root of x to the 5th, is going to take some simplifying first. Right here, I went ahead and made that 27 3 to the 3rd power inside the logarithm first, right, instead of expanding it out like we did with the 125 and then making it a base to a power. And then right here with the square root of x to the 5th, I made that x to the 5/2 in the denominator. Now right here, that x to the 5/2 in the denominator is going to expand into a negative logarithm. And right here, since that 3 to the 3rd is in the numerator, it's going to be a positive logarithm, and then we can take those exponents and represent them as multiplications out front. So right here, expanding with polynomials. So right here, we have some polynomials inside our logarithms. Polynomials, and we should say rational expressions. And what we want to do here is factor these guys as much as we can, right? And then expand them into logarithms. So I'll give you guys an idea what I'm talking about with this first one. Right here, log base 2 of x squared plus 3x. I can write that as log base 2 of, right here, x times x plus 3. Now right here what I'm seeing is a multiplication of two things in the numerator of my log base 2. It's a log base 2. And right here, what we can do is expand this out into log base 2 of x, and then plus log base 2 of x plus 3. Right? So that would be the expansion of this guy. So why don't you guys go ahead and try these two guys, and then we will come back and take a look. All right, guys. So looking at these next two, we've got the natural log of x squared plus 4x minus 12. I can represent that as x plus 6 times x minus 2, and then expand that out into two positive natural logs, right? Since right here I've got a multiplication of these two linear factors in the numerator. Now, I think that sometimes people get tempted to say, well, there's an addition inside the logarithm. That means I can expand that out into an addition outside the logarithm. Really what we have to remember is we're talking about a multiplication inside a logarithm expanding out into the addition of two logs of the same base. And so that's what we really want to be careful of here. In this next expression, we've got x squared over x plus, or x minus 2 rather. A couple ways we could think about dealing with this x squared. We could call that x times x, but what I chose to do was to say that I've got one thing that's basically being squared in the numerator, and then I've got an expression in the denominator. So when I expand this out, that thing that's being squared in the numerator is going to be in a positive common log, and that thing that's in the denominator is going to be in a negative common log, and then I can take that exponent of 2 inside my positive common log and make it a multiplication of 2 out front, right? So that's how I would choose to expand this guy.